Cheers. Okay, hi. So this is my talk about Raxx. So I've linked to my page at the bottom. The slides for this are already up there, so if you're struggling to see them or you want to skip ahead, you can just go there. So what's Raxx? This is where we're going to start. So refining, to remove impurities or unwanted elements. I thought this was very appropriate. Learning from the closure, nice definition to lead off with. So this is a good place to start a flame war, obviously. It's classic. But that's never very helpful. And I know this, so some of the titles I turned down were Elixir Unplugged. There you go, I can work out the Erlang and the Elixir developers quite quickly with this. The Death and Life of a Phoenix. Maybe I'll just leave some of them long enough for you to tweet or whatever. I suggest hashtag microservices or TDD is dead, something like that. It's a good one. And finally, Through the Plug Hole, which also didn't make the cut. Okay, so this is me, Peter Saxton. A few places on the internet as CrowdHailer, and work at paywithcurl.com. So say thanks for them letting me come out here, and I think we are hiring at the moment. So I do want to ask a few questions of the audience. So who is an Erlang developer? Or described. Who is an Erlang developer? Okay, and who is an Elixir developer? And who didn't like the question and would like to say they're both? Okay, so there's a few. All right, so it's about a 50-50 split. So I will try and I'm quite happy to take questions as I go through this. It's done from an Elixir background because I'm changing what was there before, but I will explain as I go on. This is my slow down pebble. If I speak too quickly, throw stuff at me. It's very calming. So what is Raxx? Raxx is a HTTP interface for servers, frameworks, and in fact clients now as well. And it's a toolkit for web development. This is the 101 example. So you simply have, so in use Raxx server, that sets up a behavior. One of the callbacks you need for the behavior is this handle request. Handle request takes the request and the configuration for the server, the runtime configuration, and you return a response, which is just a structure. So this is a nice pure function, data structure in, data structure out. The toolkit part of this makes it easier to do things. So this is how I would actually write it. You have these helpers to set headers, set bodies. You can just keep adding to those, set cookies, whatever you want. It's, the underlying structure is quite simple, but it's nice to use these. Again, you can do stuff with the request. I don't even particularly have much of a router because you can just match on the path, like Elixir and Erlang pattern matching. It's a very powerful thing. So there's nothing more to that, just have more clauses for more actions. And then you can take something out of the state, so you can do runtime configuration. So this is my hello world app. So how do I start one of these? So Raxx applications need a server to run them. So here I say ACE, HTTP service start link. So we set up our greetings for hi. And then I visit localhost 8080, and I'm like, ace.co. So what is ACE? So I introduced ACE as a bit of a throwaway comment there. Raxx being the interface, you need a server to run it. ACE is the server that runs Raxx applications. It's HTTPS by default. It also serves HTTP2. So that was mostly why I built it. That was something I was looking for at the time. So it's isolated message exchanges. So every request response gets its own process. Tries to be a good OTP citizen, so it's very easy to add multiple of them to a single supervision tree. So you can have an admin endpoint, an API endpoint, all in one tree. And it's got a simple interface for streaming, which we'll come back to. So just a few more things about ACE. ACE just provides some helpers around a Raxx app. I mean, you can really consider them the same thing, but there is this confusion on the naming. And what I've got here is these default arguments at the end are just arguments that are passed automatically to start link. So now I can start this without saying what port I want. And cleartext true is saying I want to serve this not over HTTPS. Because by default, it will look for the SSL certificates. So ACE is as a service for the servers. ACE is implemented. So there was this post by Joe Armstrong about why using Erlang makes it easy to write a web server. It's because you have to write a web server to deal with one connection, and then you can just put lots of those in a supervision tree. This was why I started doing this. It was just a practice project when I started. So this is the architecture of ACE. There's a load of servers which are connected to clients, and then there's one governor which is linked to one server which doesn't yet have a client. This is a pool. In real life, this diagram gets a mess, but the default is to have 100 of those. So when a new client joins, The server says it's accepted a connection. The governor just asks the supervisor to spin up a new one, and then it watches that supervisor going forward. So that's quite simple. There's not that much to it. So why build Raxx? So this is a question which obviously has a lot of context in the Elixir ecosystem. We have Plug already. So a couple of things. Functional programming matters. People go back and forwards on this. Like Elixir and Erlang are a pragmatic language. We can do very unfunctional things if we want to. But we normally would advise against it as much as possible. So if there's a way to do it without writing to the process dictionary, et cetera, it's normally a good idea. HTTP is message passing. So I wanted to make it look like just other messages internal, like Erlang messages, and then to support more than MVC, so a framework that was more than just MVC. So functional programming, as everyone put their hand up for one or the other, I'm sure you're fairly happy with this. So data is immutable, there's no side effects, and there's no side causes. That's how I shorten that one down. And as I said, Elixir and Erlang can break all of these rules if you want to. We're not Haskell programmers, and I think a lot of us like being not Haskell programmers. Sometimes it's just a lot easier. So this is my motivation for writing Raxx. This is a talk I gave pretty much exactly 2 years ago now. And it was a 5-minute lightning talk, and I said I was looking at Plug, and inside Plug, there's this con object which represents a connection. And this map has a PID, which is called the owner. And I didn't, this seemed weird to me, because everyone told me it was a nice functional interface. Why do I need this PID? Like, in various places, it calls out and pulls data from it, messing up the functional purity. So, I mean, this is the full con. Where is it? The owner is, well, I guess they're alphabetical, so it's there. This is everything that's in a Plug con. Again, I thought this was quite complicated. Maybe it needs to be this complicated, but I had a suspicion I could do something different. So yeah, this owner PID being the problem. Okay. So at that point in that talk, back in 2016, I didn't have a strong answer to this. I knew about other things, and I experimented, but it's developed a lot since then, so I want to tell us more about that. But before we go there, I just want to go over a few more of the problems that exist inside using something like this, like why functional purity is a good idea. So this is the first bug I've encountered with a, well, not bug, issue, with a Plug architecture. So we were doing message signing, so we would sign our message. So yeah, the header would have a hash and a signature of the message body. So we wanted a plug, which is just a middleware, to verify the signature, make sure that the signature was correct for the body. And then there's the standard parser in the Plug library, which will take the body and pass it into JSON or a form query or whatever. The problem with this is Plug actually pulls the body directly from the socket. So this is another one of those impurities. So you can't have these two plugs implemented in a naive fashion. If you put your verify signature first, it'll read the body, throw away the body, tell you the signature is accurate, but then when the JSON parser tries to read the body, it's no longer in the socket anymore. And if you put the JSON parser first, you get exactly the same problem. So this architecture, this was one place where I thought the composition which it goes for was compromised. And there's a solution. You can put the raw body into a private, into an assigns on the con. But to implement this, what we did was we copied and pasted the entire Plug parser file to our own code base, added this one line, and then had plug/curl, parser. So we were now maintaining a thing which we didn't want to maintain. The other issue is this one. So in our system, this caused a memory leak. And it's somewhat convoluted about how it causes a memory leak, but the problem is, so what we're going to do here is we're sending a chunked response to the client. And we don't stream a whole file. We actually stream new data to them whenever a new event happens. So in this receive block, I wait for an event, I serialize it, and I send it over the connection, so that's what this chunk function does. And then I just go back into the loop. And if I receive anything else, just put it in the con. Just return the con. So the problem with this is we can go months without actually receiving an event. Like if a user goes inactive and this process is open, this receive block never finishes. So the correct solution for this would have been perhaps to add an after. Like I've made the mistake here, but my assertion was I made a mistake because I had to drop back down to a lower level. We use gen servers to not write our own send and receives. That's a pattern it's very prevalent, to not write your own send and receives. And there was no way to do this without explicitly doing a receive, and explicitly doing receive caused a difficulty. Okay, so that's some of the problems, and for those of you who don't know plug, we now get into more interesting bits. So this is from the one of the HTTP RFCs. I just searched for message passing to find the point that most agreed with what I wanted to say, and then present it as an authority. That's what happened here. So we can see that it says that the status application so the message payloads are self-descriptive message payloads. So the request and the response they consider to be messages from the client to the server. Okay, I can see a photo being happening as we can wait. Oh, good. So this is a picture I'm probably all familiar with. So there's a message up and a message back. And if I replaced HTTP client with HTTP server with gen server, I think we'd all be pretty happy that this would make a lot of sense to us. So this is what a gen server would look like. So this is just some pseudocode where I just have a data structure. So I've got just the atom request, and I'm going to pong with the atom response. This is the simplest gen server I could come up with. And the simplest Raxx server looks like this. But you now get a slightly richer data structure for the request and a slightly richer data structure for the response, but that's what happens there. And at this point, I was pretty happy. I was like, this seems to be a good thing. This is nice. I'm feeling that this is an Elixir-y or Erlang-y, undecided way to do this. Okay. Any questions? I'm quite happy to answer them. On the way. All right, let's crack on. So what about streaming? This is why Jose Valim, who's the creator of Elixir, did not implement an interface on this style, is because you have to have the whole request in memory and return the whole response. So I have a solution to this as well. So if there's a communication where you do care about the parts of the request and the parts of the response, you can still view this as message passing, but your message is not now a request and not now a response. It's a stream of messages, starting with the head of the message, body as it becomes available, and then the end of the request, and the same for the response. And inside BEAM, messages between two processes are guaranteed to be in order, and because of TCP, all of these pieces are guaranteed to be in order. So again, the pattern seemed to continue. And this is how you do deal with streaming inside Raxx. So here we have a file upload endpoint, and we have 3 different callbacks at this point. So we have a handle head, handle data, handle tail. And because I want to deal with the data as it comes in, so when I first get a request, I open a reference to a file. There's not much error handling here. And then for each data chunk that comes in, just write it to the file. And then when I've got the end of the request, I just send a response going, yep, cool, it's here. We can see a few things about how Raxx works here. So the return types are, there's no reply, no reply that you'd be familiar with from a gen server. The return structure is the same for every callback. And the return structure is the second argument of the tuple is a new state. And the first the first part of the tuple is a list of things you want to send. So if you want to send a response head, you would put that in the list. And if you want to send a response head and a bit of a body, you could put those 2 elements in the list. The other return signature you're allowed to do is if it's the end of a request or the end of a response or a full response, you can just send the whole thing, because at that point the state is not interesting. If once you've sent the whole response, the process is going to be shut down. So you don't need to specify what your state will be. And that's what we're doing right at the end. So what about Erlang? This is some slides I've added since last time. So in Erlang, so you can use Raxx in Erlang. I have mapped the Raxx module to an Erlang-friendly term, so you don't have to do. Doesn't look too awkward. I haven't remapped the behavior because there were issues if you tried to be clever and did it the other way around. Like the behavior being specified twice was a problem. A module aliasing to another module was not a problem. So this is what your endpoint would look like in Erlang. You'd export all of the callbacks. Handle request, you would set a response, set the body. So I haven't talked about handle info callback. The handle info is the same as in a gen server. Any other message from inside your system goes into the handle info callback. And so this is the extra stuff you have to do because Erlang doesn't have macros. So inside Elixir, the main difference being when I said use Raxx server, it came up with default implementations for these. So the default implementation for handle head, handle data, handle tail is to bundle all the data together, and then when you get the end of the request, shift it up the stack. So here, if the body's false, then we call the handle request function with the full request. If there is a body, which will be indicated by the body being true when you get handle head, we just add all the data to a buffer, and then when we've got the tail, we stick that full body onto the request and pass it up the stack again. So you have to, as far as I'm aware, I've not been doing much Erlang, but as far as I'm aware, these have to be put into your controller, or your action endpoint. But these are default if you use the Elixir interface. OK, so quick look at time. So one of the other goals of this project was to make a framework or a toolkit which allowed you to do more than MVC. BEAM is very interesting. I've heard stuff about React Core and a variety of other things. Like an N-tier application being the default seemed just like slightly disappointing in some ways. Like it's a very practical thing to do to get work done, but I wanted to do more than that and experiment with a bunch of other things. So these are all interesting architectures. We use event sourcing at work. I'm also very interested in the memory image. You can just Google that and Martin Fowler. There's an interesting talk about that. And Raxx supports all of these architectures because it supports none of them. You're on your own. That's how we do it. So this is how I term this: mind your own business view controller. And this is what Raxx does. You have controllers. There is also some help for the views, which is basically translated as the controller is help with passing the request, and a view is help with building the response. That's how I made that. And your business logic, I don't care. I mean, I'm interested, and tell me about it, but I'm not helping you. That's not what we're going to do here. So mind your own business view controller. That's the motto of Raxx. So the Raxx stack now looks like this. Cowboy has been replaced by Ace. There's no fundamental reason for that. Raxx as an interface could have other backends. When I started doing this, Cowboy didn't support HTTP2, and I wanted that, so I made Ace. This rabbit hole got quite long at that point. Plug is replaced with Raxx, and Phoenix, I don't go there. I don't use, well, I do at work sometimes, but we have some services without the framework at all. We do use the Ace Raxx nothing stack at work. So that's how I do that. So no framework. Isn't this a bit reinventing the wheel? I would argue no, as long as you've identified a reason why what you're doing is different from the defaults. And it's because Elixir is not like other languages. If I said I wasn't going to use, if I said I was going to implement a server and a framework in C, just have it. That would be a different category of problem than me saying I'm not going to use a framework in Elixir or Erlang. And the reason is supervision trees, OTP, they're all bundled in with Elixir Erlang. They're an excellent framework. I've heard, the OTP framework is the way I've heard it described. Then Mix, which is the Elixir project manager, that tells me how I'm going to structure my project. It has stuff for configuration. So between those two things, there's a lot of a framework around. It's just not another framework. So this gives me enough structure to carry on quite happily. OK. So frameworks save time. Why reinvent all these little pieces, no matter how small? Well, do they? That's the question I ask a few times. So this is the JavaScript world as of 6 months ago. So it's not the JavaScript world anymore, which is the important thing. Phoenix recently switched from using Brunch, which isn't even on here, this particular graphic, to Webpack, which is a good call. Apart from maybe they should use Parcel. It's an opinion that could be had, or any of the others. I like Rollup. You don't need to know that, but I do. It's not a JavaScript talk, but it's nice. Check it out. So the framework saved time. So this was one of the things with Phoenix. When we had an application which had JavaScript, CSS, and all of those things, I was like, OK, I won't challenge that. The first service we switched to Raxx was an API endpoint. There's a lot of stuff in Phoenix we can all see it's not used. And the managing node dependencies, that seemed like one where it probably saved a lot of work for me. But again, OTP's got you covered. So this is a package.json. So ask your front-end colleagues about this if you don't understand, which is the point I'm making here. If you want to split up the team, they can give you this. And the interesting thing here is I've got a script called watch CSS. So if I do npm run watch CSS, it will build my CSS, and I can serve it. This is all I need to do to supervise that node process inside my running application. You should only do this in development, makes things easier. But system is a module that helps you run command line. And then Elixir gives you tasks. So if I start a task, which is running this watch task, that'll rebuild my CSS every time I save a file. And with a library which is called xsync, which is a little reloaded Erlang recompiler, which happens when a file changes. And you can also tell it to watch CSS files. this is everything I need. Like, it works. That's the end of my adventure into JavaScript. So this is something I wanted to bring up. I was going to demo, but I decided it was safer to just use their laptop here, so I won't be able to demo this. But Raxx Kit is the nearest thing to a framework that exists. It's a beginner toolkit. If you want to try a Raxx Kit thing, you can install this archive from Hex, and you can run mix Raxx Kit my app, and you'll get an application, which is a web server. It'll give you some self-signed certificates, so you can try the HTTPS and HTTP2 endpoints. And then there's additional flags. So instead of flags to take stuff away, which I think is just a fail with the framework, there's flags to add things. So you start off with the minimum amount of stuff, and if you want a Docker file or a node asset compilation, you add those as you go along. Okay. Any questions at this point? Everything makes perfect sense. Well, that's handy. Okay. So let's go through and build something with this. So a chat app, that's I'm not sure if it's been done before. We'll see. We'll see how easy this is. So the first thing, so I'm not even going to use Raxx Kit going through this. I'm going to do everything from hand because it's not even that hard. So what do we do? How do we start a new Raxx project? Well, it's not a Raxx project. It's just an Elixir project or Erlang project. So you use mix new water cooler, and we are going to start a supervision tree. So that's the flag we need here. And then we go into that. So this is the application. And this is nothing to do with the web. So I have to write all of this. So for a chat app, I need to be able to publish a message, and then I need to be able to join a channel. And this water cooler, there's just one channel. There's one global channel. You can throw a message in, or you can listen to the messages being thrown in. So how does this work? Well, like this. So message goes in the back, and it just gets delivered to everyone. I'm not going to show you any code for how to do this. I told you it wasn't the Raxx thing. So once you've got this module working like this, let's expose it. So we're going to use server-sent events, which is something. So how many people know about server-sent events? This number, this really needs to go up. These are excellent. They're a really nice way to stream stuff down. They have a couple of helpers for reconnecting. So there's a last event ID header you can add to them. Whereas with WebSockets, you have to rebuild everything from scratch. It's just a dumb pipe. So they're nice. So we need our main page. So in this handler, we have so at the top we have get homepage. So path is a list of segments. So the empty list is the homepage. This is the one thing that Raxx does to make your life a little bit easier. Pattern matching on a string doesn't work that well. Pattern matching on a list of path segments is a nice trade-off. And we're going to send the homepage. So the homepage at this point is just the string homepage. And in this router, to deal with a 404, just match on all, send a 404 page. And then to start this, we can, so because we've used Ace HTTP service at the top, we can just add it to the supervision tree like this and add our config options. So our options will be port 8080 and just send it over clear text. So I said Raxx was a toolkit. I mean, there are things it's helpful to have, and there's this minimal router. It's just a very simple macro that you give it any pattern you want to match on the request, and then a module to call with instead of the module it was in. So at this point, we have a home page and a not found page action, and they're just routed by each match. So the bottom one again, the underscore just match on anything. And our home page is now a little bit more interesting. So our home page action, we have the same handle request. So each action is exactly the same as a full application. There's no difference in API there. Handle head, handle body, handle request are all available. And again, so I'm just using EEX for the page here. So this is another thing which I'm not doing for you. There are excellent tools for turning a template into something to send. So we just use that. We can then have another helper we have is Raxx static. Sorry for the Erlang people. I have no idea if this is. I think this is very macro built, so I don't think you can use these things at this point. It's not for you, unfortunately. But I'll look into it some more. And so this is just saying that I'm going to everything inside the public directory. I'm going to serve that first before continuing up the stack. So if there's a favicon icon in there, we send that back instead. So in this case, the requests essentially hit the bottom middleware first, so everything's logged. Then if the path is to get main CSS or favicon.ico, that one returns and it doesn't go up to the router, and then the router is the last one to handle it. Now we have to deal with that page. So this is the home page. This is how we're going to send a message. We're just going to post, just post the data. And this is going to be the endpoint that deals with that. So here, we're using handle request because the body won't be that large. We pull it out, we decode it. Again, we're just using standard tools to decode the query. And then we publish the message, and then we redirect back to the home page. So this is where it starts getting a little bit interesting, because this is where we're now dealing with the stateful situation with our requests. It's not just a one in, one out situation. So what happens here is we've got the, so at this point we don't need to match on the request coming in. The router's already taken care of that. I don't need any data from it. We join the chat room. So this just registers the current PID as a place to send messages to. And then we send a response. So the interesting thing about this is when we set body to true, that says that this request is not yet finished. That says when we return this, don't put the empty string, don't close it out straight away. There's going to be a body to follow. I just haven't told you about it yet because I don't know about it yet. And so this is where we need to return the list of parts, which is the response head, and then new state to carry on with. And then, so whenever we get a message from our water cooler chat server, so this was the format for the messages, we just pattern match out the message, we serialize it as a server-sent event, we say it's going to be part of the data, which is part of the body. So our list of parts to send to the client is the data serialized, and then we just keep going with our state, which here I've called config. Keep you on your toes. And so this is the JavaScript for our chat app. This is it. You can. So what this does, we have. So the reason server-sent events are so nice is this JavaScript API called event source. So this is in all the browsers apart from Internet Explorer, and I think it's also not in Edge, but there are polyfills for it. And all you do is you give it a URL, which will give you this event source. And then whenever an event is streamed down in a chunk, it'll just call this onMessage function. So in the onMessage function, we just update the display. So whatever we get, we pull the data off, we put it in a div, we stick it to the page. There's probably a few improvements to be had here, but that's everything you need to make it work. So that's a fully functioning chat app at this point. So